Friends, welcome to ehiddenbrain.com. Today we'll see infinite sets. Infinite sets. Now, the infinite sets is divided into two subparts. One is countably infinite set, and second is uncountably infinite set. Okay. Now, first of all, what is the infinite set? Infinite set is a set which consists of an infinite number of elements. Like for example, set of natural numbers is an infinite set because it starts with 1, 2, 3 and it goes up to infinity. That's why the cardinality of mod n is infinity, I can say, because there are infinite numbers in it. Right? Now, what is countably infinite and uncountably infinite? Now, countably infinite set, let's talk about countably infinite set. Countably infinite set is called as denumerable set. It's called as denumerable set. Now, what is countably infinite set? Countable infinite set, right? It means actually we can have, it doesn't mean that we can count the number of elements. It is not in that sense. It means we can have a bijection of the numbers. For example, let's say set of even numbers, or let's say positive even numbers, right? So set of positive even numbers denoted as E plus, which is 2, 4, 6 up to infinity, is countably infinite, right? So it is countably infinite. I will denote this countably infinite for time being as Ci, and this is Ui, you can say, is Ci. Why it is countably infinite? Because we can have a bijection, because we can have bijection with respect to n. Now, what is bijection with respect to n? It means, let's see this. Actually, I will show you that bijection here itself. From n to e plus, I can have bijection like this: 1, 2, 3, 4 and up to infinity, and then all the numbers from this set can be given to the indices like 1, 2, 3. So means 2 will be on the first index, 4 will be on the second index, 6 will be on the third index, 8 will be on the fourth index, and that way I can have a bijection here. You can see this is a bijection, right? And hence the set of even numbers, any even numbers, positive or negative, doesn't matter, right? Or set of even number itself is countably infinite set. Even a set of natural number itself is countably infinite, because there is a bijection from n to n, and where I can have the elements 1, 2, 3 up to infinity, and then again 1, 2, 3 up to infinity, and this is a valid bijection, I can say. So how many? So I can say that set of natural numbers, set of even numbers are countably infinite sets. So, right? So I can say set of n, e plus, e minus, etc. are countably infinite. Now, I hope you understood what is countably infinite. One more definition of countably infinite is, if we know nth element of the set, if we know nth element of the set, we can guess n plus 1th element of the set, n plus 1th element of the set. For example, set of natural numbers 1, 2, 3. If I know nth element as 3, then definitely n plus 1 element will be 4, something like this. And set of even numbers, set of even positive numbers, I can say 2, 4, 6. If I know the nth element, I can let you know the n plus 1 element. Definitely it will be 8 because it's even number, so you have to add. Now there is one set, let's say x. Now you can see this 2, 5, right? I am adding 3. You can see that 2 plus 3 is 5, 5 plus 3 is 8, like this. 11. If you know this nth number, I can definitely able to let you know the n plus 1th number, and that way these sets are countably infinite sets. I hope you understood countably infinite sets. Now what is uncountably infinite set, right? What is uncountably infinite set? Uncountably infinite set, you can say this, uncountably infinite sets are the sets where in that, if we know uncountably infinite sets, uncountably infinite sets, right? Uncountably infinite sets. If we know nth element, if we know nth element of the set, then we can't guess n plus 1th element of the set, n plus 1th element of the set. For example, set of real numbers between 0 and 1, set of real numbers between 0 and 1 is uncountably infinite. Why? Because let's say this set is denoted by s, then what I will be having, s will be equals to, it will start from 0, then I can have 0.1, I can have 0.0.1, I can have 0.001, something like this I can have, right? So I can have 0.012, something like this. Now if I know nth element, let's say this is the nth element, I can't guess n plus 1th element, right? I can't guess n plus 1th element. Am I able to guess this element? No, this is not possible, right? And hence the set of real numbers between 0 and 1 is called as uncountably infinite set. Similarly, set of real number itself is uncountably infinite set. Why? Because in set of real numbers, it's a set of real numbers is also uncountably infinite set. Okay, now one more thing, set of, let's say P of n is also a uncountably infinite set where n is set of natural number, and P is power set. Now why P of n is not countably infinite, why it is called as uncountably infinite? Because there is no bijection as such. Why there is no bijection? Let's try to have a bijection between n to P of n. Let's try to have a bijection between n to P of n. Now what I will have, I will try to have a bijection between n and P of n. It means natural numbers will be there. There should be a bijection between the natural numbers and this power set of n, right? If it is countably infinite. But you can see this, it is not a countably infinite set, because if I take a power set and one of the element of power set is a single element set, right? So I can set 1, 2, 3, 4, and then this will go itself to the infinity, right? So this looks like a bijection. But what about when you get a bijection, or when you get a mapping for 1, 2, when you get a mapping for 1, 2, 3, when you're gonna get a mapping for 1, 2, 3, 4? So this is questionable, right? So these things is questionable. You will never able to get a mapping for these elements, because the list of single elements, right, or a singleton sets is itself is infinite, and then you will not be able to get a bijection or the mapping for a lot of elements, and hence I can call this as power set of n is uncountably infinite, infinite because there is no bijection. There is no bijection possible. There is no bijection possible. I hope I discussed why it is not possible, because this singleton sets itself is an infinite set, and then you will not have the mapping for the remaining elements, which is having 2 elements, 3 elements, 4 elements, and that's what the P of n itself is a uncountably infinite set. Similarly, the fourth set is there, right? Set of irrational numbers. Set of irrational numbers is also uncountably infinite sets. I hope you enjoyed it. If you liked it, do like it, do subscribe to our channel for further videos, and if you have any doubts regarding this, please put it into the comment section. I will definitely get back to you. Thank you.